Hello everybody, I'm going to show you through this video on how to factor, and actually what I'm going to do is I'm going to factor by GCF. Factoring in algebra is very important. It's going to be used quite a bit, and there's many different ways to factoring. So the first way is factoring out a greatest common factor from your polynomial. So I'm going to start with a very simple example. That would be 2x squared plus 12x plus 4, and you're going to be asked to factor something like this often. We'll get into later as to why you would want to factor, but right now we're just going to be working on the skill of factoring. The very first step you should always do when you factor is to try to factor out a greatest common factor. This is a trinomial, so you have three terms, and you're going to look at all three of those terms. You're going to find out the largest number, greatest number, that is common to all three of these, a common factor, hence GCF. So what goes into 2? Well, only 2 and 1. What goes into 12? Well, lots of things. A 1, a 12, a 2, a 6, and a 3, and a 4. And what goes into 4? Well, just a 1, a 2, and a 4. So if you kind of listed all those factors, the greatest number that is common to all three is the number 2. So I'm going to pull out that 2, and I'm just going to write what's left. So if I pull out the 2, I just have a 1 there, so I don't need to write the 1. I'll just write x squared. And if I pull out a 2 from 12, 2 times what's 12? A 6, and I still have the x. And if I pull out a 2 from 4, I'm still left with a 2. This is how you'd factor this one simple problem by pulling out a greatest common factor of 2. Let's move to a second problem. Second problem I'm going to make up would be like 10x squared plus 15x and plus 5. Now if I listed the factors of 10, I'll just kind of list them up here. It's 1 and 10 and 2 and 5. So those are all the factors that multiply to 10. Then if I did 15, 1 times something is 15. You can always use the 1, but we'll never pull out a 1. But 1 times 15 is 15. And then 3 and 5. Now you may need to list these factors, I'm not sure, but I usually don't have to. I can just think through it. The only thing that multiplies to 5 is 1 and 5. So now looking at all three of these lists, which number is the same in all three lists? Well, 5 is here, here, and here. Yes, there are 1s, but the greatest number is 5. So I'm going to pull out a 5. And essentially all you do to figure out what's left is you divide. 10 divided by 5 is 2. So I have a 2 left, 2x squared. And 15 divided by 5 is 3. So I got a 3 left, and don't forget your x. And now here's a tricky one. This one's often forgotten. Oh, if I pull out a 5 from 5, there's nothing left. So people like to leave it empty. Well, you can't leave it empty. You have to hold its place with a 1. The reason for that is if you did the distributive property, you should get your result at the beginning. 5 times 2 is 10x squared. 5 times 3 is 15x. And 5 times 1. Now, if I didn't have that 1 there, I wouldn't have anything here. But I need to have the plus 5 because that's what my original problem said. So now looking at my answer is right here in this orange circle. It is the pulling out of the 5 from this original polynomial. And once again, we will get into later as to how you're going to do that, or why you're going to do that. Just looking at another one, for example, let's just pretend I have something like r instead of x. R squared minus 8r minus 4. Now, there are times when you look at this and you say, well, what's here? There's a 1 here. What goes into 1, 8, and 4? The only thing that goes into 1, 8, and 4 is 1, because that's the only thing that goes into 1. So there are times when you can't actually pull out a greatest common factor, so you would just leave it. This one you would say is already factored. So sometimes that happens where you actually can't pull out a greatest common factor, so you just leave it. And then it does get to be a little bit trickier. For example, let's go with, let's undo that. Let's go with 18x cubed plus 6x squared and plus 9x. Now, this one's a little bit trickier because it's got an x cubed. That's interesting. Well, let's look at the numbers first. 18, 6, and 9. Now, if you're pretty good with numbers, you should be able to figure out what goes into 18, 6, and 9. If you're not good, you might have to list the factors. I know that 3 goes into 18, 6, and 9. I know that 6 goes into 6, and 6 goes into 18, but 6 doesn't go into 9, unfortunately. So I guess I'm going to have to just pull out the little 3. So I start pulling out the 3 and write the leftovers here. But the other extra piece you have to take into account is the variables. So look at these for a moment. One of them is x cubed, which is xxx. One of them is x squared, which is xx. And one of them is just a single solitary x. So if you look at all 3 of these positions, I could actually pull out an x from all 3 of those. So I will. So what am I left with? 6 times what's 18? I'm sorry, 3 times what's 18? That'd be 6. And now how many x's am I left with? If I pull out 1 from 3, I'm left with 2, x squared. And then if I pull out a 3 from a 6, I'm left with just the number 2, because 3 times 2 is 6. I pulled out one of these x's, so I'm left with an x. And then 3 times what is 9? 3 times 3. So then if I distribute that in, I get 9x. If I distribute this in, I get 6x squared. If I distribute this in, I get 18. That's just a visual check to see if it worked. It worked. This is how you factor by GCF. This is always the very first step you're going to do when you're attempting to factor.